Yes.
Okay, so today we're using tree diagrams to solve problems. We're going to see tree diagrams. Just to get started, have a go with this do now exercise. Take a couple of minutes to solve the problems to recall what we've seen last lesson. Okay, welcome back. A bag contains 5 red balls and 3 blue balls. One ball is drawn and replaced, then the second ball is drawn. What is really crucial about this question is whether it is with replacement or without replacement. Take extreme care whether replacement occurs or replacement doesn't occur. So when the first ball is drawn, there is a total of 5 red balls in the bag. So the probability that the first one is red is going to be, there are 5 red balls and there are 8 balls in the bag. 5 over 8. The second question, we want the probability that the second is blue. Now because the red ball has been replaced, how many balls are in the bag now? 8. Because the red ball gets replaced, there's still 8. In this case, it's going to be 3 out of 8. Now for the third question, would it matter whether that was the 3 out of 8? Would it matter whether that was the first ball drawn or the second ball drawn? No. It's still going to be 3 out of 8. So in this particular case, the events are independent. And this is because of replacement. This is because of replacement. If the ball wasn't replaced, what would the probability in the second case be?
3 over 7.
In the second case, would it be 3 over 7? It depends on what the first ball out was. So it gets much more complicated when there isn't replacement. We need a much more complicated approach, and a tree diagram would allow us to solve that type of a problem. We have 2 different possibilities that depend on what was the first ball that was drawn. Obviously it's going to be out of 7, we can see that that one goes down, but it would depend on what happened first. So then it becomes much more complex, and we need a solution for this. And we use tree diagrams that look like this one. So here we have a question. Michelle is playing a game. In the game she must flip a fair coin, which will result in the coin landing on heads or tails. If the coin lands on heads, she wins the prize. If it lands on tails, she has another chance, but this time she must roll a fair 6-sided die and get a 5 or a 6 to win the prize. Otherwise, no win. So, find the probability that Michelle did not win a prize. So in order to do this, we must start off by completing the tree diagram. We must complete the tree diagram by writing in the missing probabilities. Let's do that one together. So if the probability of winning on the coin toss is 1 over a half, what is the probability of not winning?
1 over half.
1 over a half. This one is always the complement of the other one. It's always the complement of the other one. So what is the probability of winning the second time with the 6-sided die?
2 over 6.
2 over 6? Which why 2 over 6?
Because it's a 5 or a 6 and it's out of 6 sides. So
Yeah.
we have 2 out of 6 sides.
We have 2 possible outcomes out of a total of 6 outcomes. And that would simplify down to 1 out of 3. What's the probability of not winning?
4 over 6.
This one's going to be the complement of 2 out of 6, or 1 over 3. So the complement of 1 over 3 is 2 over 3. The complement, just to remind you, is 1 minus the other probability. Find the probability that Michelle does not win a prize. So to not win a prize, Michelle has to come to this leaf on the tree diagram. This is the only place you can get to not win a prize. She has to come here to this leaf. There's 3 leaves. There's this win here, there's this win here, and then there's the no win there. Those are the three leaves. To find the probability at a leaf, take all the probabilities of every branch along the way and multiply them. So to find the probability here, we come down this pathway in order to get there, take all the probabilities that we pass and multiply them. So in this case, the probability of no win is going to be first she has to not win the first one, and then she has to not win the second one. And this will give us 2 out of 6, 1 out of 3. This is the probability of not winning a prize. Given that Michelle won a prize, find the probability that the coin landed on heads. So what this one is asking is that we know she's won a prize, but we want it to be that one, not this one. And we know that this didn't happen. Discuss with the person next to you how you might solve this particular problem. Take a couple of minutes for yourself, and then I'll do it on the board.
Because it's going to be 1 times 2/3.